Okay, so this says to find the exact value of cosine of pi over 6 plus pi over 4. So pi over 6 is on the unit circle, pi over 4 is on the unit circle, but if I actually added them together, I believe they're 5 pi over 12 together. So that wouldn't be on the unit circle. We can use these formulas up here that says cosine, and it says plus, so I go to the one that is cosine u plus c. And I just use this formula, and I'm going to use those values. We're going to write down, by the way, write small. Write small. We're going to use the formula cosine pi over 6 cosine pi over 4 minus sine pi over 6 sine pi over 4. So that was just coming from the formulas.
We need to memorize.
Good. Bless you. Hi, and then, but you do have to have memorized what's cosine of pi over 6. Yeah.
The radical 3 over
3 over 2, and then the cosine of pi over 4 is radical 2 over 2, and then the sine of pi over 6 is a half, and sine of pi over 4 is radical 2 over 2. So that would be the pre-calc part, would be that you have those memorized. Other than that, now we're just going to multiply fractions, and we're going to have radicals, so we just need to make sure we know those rules. But that comes from previous courses, so that's review. So multiplying fractions straight across, and how do you multiply when you have radicals? You actually multiply the 3 and the 2 together?
Yes.
Yeah. So we have square root of 6 over 4. And then over here, I have a 1, and I have a square root of 2. Can I multiply those together?
Wait,
Yes.
I mean, it's 1, so like radical 2.
It would be 1 radical 2. I'm going to write it as radical 2. So you don't multiply the 1 underneath, is my point. So outside of it. But you can't really tell. Over 4. So that we multiply with radicals. How do we add or subtract with radicals? We need to now subtract these.
Then you can break it up in radicals.
Do they come in denominators, so it's all good?
Ooh, interesting that you said that. Nobody else said that. I'm sorry, the denominator? I didn't hear what you said.
Yeah, is it what they have common denominators? So you can
Yes.
as the regular?
How do you subtract them?
I mean, 6 minus 2 is 4, right?
Not 6 minus 2, though.
That's good.
Square root of 6 minus square root of 2. Do you know the square root of 6? Is that like the square root, you know? So when they're not the same radicals, you cannot subtract them. It's like they're not like terms. So you have to know you can multiply them, but you cannot subtract them if they're different. So that would be an old rule that we are seeing again. So really, I can't do anything else other than that. Now, you can kind of check to make sure you're doing these correctly on your calculator. If you grab your calculator out, you can kind of check. Not totally check, but kind of check. If you type in your answer, square root of, oh, that's not my answer, is it? Oh, is it my answer? Okay, that's it. You type in the answer, square root of 6 minus square root of 2 all over 4. If you type that in and you hit enter, you will get a decimal approximation of it. Okay? To check your answer, let's also type in cosine pi over 6 plus pi over 4. Make sure you are in radian mode. So if you also type in cosine pi over 6 plus pi over 4 and you hit enter, they should give you the same answer. So I'm not really checking if I've simplified it far enough, but I'm at least checking that my simplified answer is equivalent to the original question. Okay. Because you didn't type it in right. If you do not have a calculator that does if you don't have a calculator that does the fractions, you would need to make sure that you tell the calculator to do square root of 6 and square root of 2 before you divide by 4. Oops, thank you. I tried, it just didn't work. So you would just need to make sure you have an extra set of parentheses there if your calculator doesn't do the fractions. See, and that's why we're trying it right now in class, so that you know how to do it on your own later. Okay. So that was just using the formula. Most of the time, they're going to give you something more like this, where you're finding the tangent of an angle, but you don't know which formula you're using yet. So they give us tangent of 15. We have to find the tangent of 15. This one's going to take up a lot of space, just so you know. I know I'm using one of these formulas, so I'm either adding two numbers together that are going to equal 15, or I'm subtracting two numbers that are going to equal 15. Because 15 is not on the unit circle. So I need to pick two numbers that are on the unit circle so I can find the answer. So how can we make 15 using the numbers, the angles on the unit circle? You know, 45 minus 30. Yeah? So if we write this as tangent of 45 minus 30, then we can use that formula and we will know all the answers because we know tangent of 45 and tangent of 30. So we're going to have tangent 45 minus tangent 30 over 1 plus tangent 45 times tangent 30. Go ahead.
Oh, you subtract the top, so yeah.
Why did I put a plus sign on the bottom?
Yeah, I didn't realize they were like switch.
Yep. Just using the formula, that's all. Okay, so what is the tangent of 45? 1 minus tangent of 30. And then on the bottom we have 1 plus tangent of 45 is 1 times radical 3 over 3. Okay. So now we're going to visit previous courses where I cannot leave a fraction inside of a fraction. I can't leave a denominator that has a radical in the denominator. So there are things that I need to do to manipulate this. And there are different ways of manipulating this. I'm just choosing one way. You could do it a different way. I am going to first get rid of the fractions inside the fraction. And to do that, you can multiply by a value of 1 in disguise. So I multiply the top and the bottom by 3. That will cancel out any denominators that have a 3. So that will give me 3 minus radical 3 over 3 plus radical 3. Okay? So I got rid of the fraction inside of the fraction. I still have a radical in the denominator that I cannot have. So again, this is previous course. To get rid of the radical in the denominator when you have 2 terms in the denominator, you have to multiply by the conjugate. So we're going to multiply the top and the bottom by 3 minus square root of 3. So the conjugate is just whatever's in the denominator, change the sign in the middle. So the denominator was 3 plus radical 3, you make it 3 minus radical 3. And then multiply by the same thing on top. How do we multiply those? FOIL. So we're going to FOIL the top and FOIL the bottom. So if you just wrote down my answers, how did I get those answers? Can you do it on your own? So we did FOIL on the top, we did FOIL on the bottom. When you multiply conjugates, the middle cancels out. And that's why we did that on the bottom. What do we have now? We now have 12 minus 6 square root 3 over 6. I saw some of you do this last week on your quiz. You cannot cancel those 6's out. Because 6 is dividing the entire fraction. You cannot just cancel those 6's. What you can do is you can factor out a 6 from the top, like GCF, factor out. Then you can cancel them. But you cannot cancel them when there's subtraction in between terms. So how can I check to make sure I haven't made any spelling mistakes? How can I check? Okay, so let's go type it in our calculator. 2 minus radical 3, I'm going to type that in. And I have it on this one too. Yeah. Oh, can you tell? Oh, there we go. 2 minus radical 3. All right, so that's what I should have. And then how do I type in the original question? Tangent what? The original question. Tangent 15. What do I have to do to type in tangent 15? Huh. Degree mode. You probably were just in radian mode. So they should be equal if you've done it right. And if you typed it in right, of course. Okay, I'm not going to check every single answer during notes. You can give the option of doing that just to make sure you're doing it right. I'm going to show you how to do it. All right. Look at the next one. So the next one says, find the cosine of 11 pi over 12. Do we know 11 pi over 12? Like that one on our unit circle? No. Okay. Or are you telling me what it was equal to? So what we're going to do instead is we're going to either add or subtract two angles that we know to give us 11 pi over 12. So I would just start by saying, well, that's the same thing as 10 pi over 12 plus 1 pi over 12. Are those angles that I know on the unit circle? No. How about that's the same thing as 9 pi over 12 plus 2 pi over 12. Are those values that I know on the unit circle? If they reduce, then that's 3 pi over 4 and pi over 6. And those are on the unit circle. So you want to just kind of goof around, like start trying values to figure out which ones you're actually using. And this is cosine. And it's addition, so we're going to go back and use our addition formula for cosine, which says cosine, cosine. Cosine 3 pi over 12, or 4, cosine pi over 6, minus sine 3 pi over 4, sine, I just totally wrote that wrong, sorry. Sine pi over 6. So that just came from our formula, then we should know our values. What is the cosine at 3 pi over 4? You're not sure? Draw a picture. There's 3 pi over 4. It's got a pi over 4 reference angle. So it is negative square root of 2 over 2. Because it's in the second quadrant, it's negative. And then cosine at pi over 6 is square root of 3 over 2. Minus sine at 3 pi over 4 is a half. Sine at pi over, just kidding, it's not a half. It's wrote the wrong one. Square root of 2 over 2, and then a half. And then what do we do next? Multiply? Can we multiply radicals together? Yes, you can multiply radicals together. Can we subtract radicals? Not if they don't have the same number underneath them. So I get negative square root of 6 minus square root of 2 all over 4. All right, I want you to try the next one. And I'm going to pause the recording. Help me remember to unpause it. Have you try the next one on your own? Most of you on your paper either wrote sine 30 plus 45, or you wrote sine 45 plus 30. Either of those will work. You'll get the exact same answer as somebody who did it using the other one, if you've done it correctly. Sine of B. So you should be doing cosine of 45 and then sine of 30. So it should be for that I put two different answers up, but they aren't different. They're just the same, just in a different order. So if you got it, you're ready to go on, go ahead and go to the next page. If you're still working on it, take another moment. Okay, this next page is just saying when you look at sine 60 cosine 45 minus cosine 60 sine 45, which formula were they using? Which formula is that equivalent to? So you might have to flip back, or you can see mine, maybe it's kind of small. Here it's subtraction. So I know it's one of these two. And then I look and this says sine, cosine. So it has to be which one? This one. So I'm just going to rewrite this as sine of 60 minus 45. And then I'm going to simplify that. And I'm going to rewrite it as sine of 15 degrees. Now, if you look at the original question, if you look at that and you look at the simplified answer, you ask yourself, which one do I know the values for? Do I know it for this one, or do I know it for sine 15? Because they're equivalent. Which one do I actually know the unit circle values for? Right, so if you were asked to evaluate this, you wouldn't use that one, you would use this one. But it might be the other way. You might not know these, but you could find that. So you're going to see that in your homework. You have to like do this, and then it says evaluate it, but you can choose which one you're going to use. You can use the first one or the last one, depending on which one you know the values for. All right, B, I noticed that it's subtraction, so it's got to be one of these two, and it starts with cosine, cosine. So which one is it? The cosine. Oops. So it's going to be cosine 45 plus 120, which is cosine 165 degrees. What does it mean if I don't put the degree symbol?
Radian.
It means radian. So you need to put the degree symbol for this degree.
You can put the degree sign on the 45 and plus the 100.
I mean, technically you should, but that's just my word, so I was being lazy. You make sure you have it in your answer, because I'll mark it wrong if it's not in your answer. All right, and then the third one, I think it's one of the tangents. It starts with a minus on top, so which one of those is it? The tangent with the minus, so we do tangent, I'll stop being lazy. 68 degrees minus 115 degrees, which is tangent negative 47 degrees. That's all it's asking you to do. For that one, I wouldn't even be able to solve it, because I don't know tangent of 68 or 115 or negative 47. So I would just have to type it in my calculator, basically. All right, now, I know I like drawing pictures, but I'm not just drawing pictures because I like drawing pictures. I'm doing it because it helps. So when I tell you to draw pictures, draw pictures. I was grading your quizzes. And those of you that can't do that quadratic formula question and you didn't even draw pictures, you guys have got to draw them. Not everybody has to do it. It would help a lot. So the first part says find the exact value of the trigonometric function given sine of u is 3/5, cosine of v is negative 5/13, and u and v are both in quadrant 2. I'm going to draw two pictures. I'm going to draw one for sine of u. I'm going to draw a second one for v. They're both of them are in quadrant 2. And it's telling me that the sine is 3/5. So I put y over r 3/5. Huh?
Oh, wait, no.
You draw them there for.
You mean location on my paper? I just put it over by the word sign. And then the v, I labeled it v, so I remember which one's u and which one's v. Second quadrant, cosine is x over r. So I'm going to put negative 5/13. I drew pictures. I've labeled which one's v and which one's u. It says to do sine of u plus v. So I use my formula. for sine when I'm adding them. That says sine u cosine v plus cosine u sine v. That's just the formula. Do I know my sine of u? Yes, 3/5. Do I know my cosine of v? Yes, negative 5/13. Plus, do I know my cosine of u? I can figure it out by going to my u and finding the adjacent, or the x value over r. So what is that? So close. -4. Remember, second quadrant, so -4. So yeah, that'll be -4/5. And then the sine of v, same thing. I'm going to go to the v triangle, and I'm going to find the y value, which is 12/13. So what if they were not triples? Pythagorean theorem, right? So now I just multiply and simplify. -15/65 plus -48/65 is -63/65. So try the next one on your own. Draw the pictures, find the other angle, or find the other sides, pull up the formula. This one's the V, but it's quadrant. So you put this on one quadrant. I'm going to draw the two pictures while you guys are working that one out. I'm going to draw the two pictures, because if you set them up wrong, I'd like you to know before you go too far. Trying to see why you got an error.
It's presented. It's
Oh,
That was you. Right, so the formula is, what is it? Cosine U, cosine V, so we're gonna do cosine of the triangle that has U. So the cosine of this triangle is negative. I should have just put that there. Negative 7/25, and then the cosine of V is negative 4/5. Then we subtract the sine of U, which is negative 24 over 25, and the sine of V, which is negative 3/5. You should get 100 over 125, which reduces to 4/5. You're done. All right, we just have one last question. The last question has your favorite word. I say sarcastically. Verify. It's like when we were doing all those identities, you had to verify. That means you do all the stuff to one side and show that it equals the other side. So which side should we work with? Left. So we're going to leave the right side as is. And we're going to do sine 3 pi minus x. Well, that is a subtraction, a difference formula. So we'll do sine 3 pi cosine x minus cosine, bless you, 3 pi sine x. And then we need to know what the sine of 3 pi is. So I'm going to draw a picture, and I'm going to go around 2 pi, and then another pi, so I'm sitting at 3 pi, which is the ordered pair negative 1, 0. So what is the sine of 3 pi? Cosine x, I cannot do because I don't know what x is. Minus. Now I do the cosine at 3 pi, so same place. What's the cosine there? Negative 1 times sine of x. So I've got 0 plus sine of x. So sine of x. Alright, so be careful with your fraction and radical rules. Ask questions, check answers. You've got 10 minutes to work on it now. Should at least get 4, 5, or 6 of them.
Is it all 20?
Yeah, 20. There's the next worksheet is for tomorrow. It's already attached to the worksheet. It's just worksheet 1.
worksheet 1 like
It should say worksheet 1 on it. The other one doesn't say worksheet 2, but.